Did you know that most successful website hacks don't happen because hackers are geniuses? They happen because developers make common security mistakes. That's exactly why the OWASP Top 10 exists. It's the world's most recognized list of the most critical web application security risks. Whether you're an aspiring ethical hacker, web developer, cybersecurity student, or bug bounty hunter, understanding these vulnerabilities is essential. In this video, I'll explain all 10 OWASP top risks using simple language and real-world examples, along with practical ways organizations can reduce these risks. This video is for educational and cybersecurity awareness purposes only. Let's get started. 1. Broken access control. Broken access control occurs when users can access resources or perform actions they shouldn't. Example: imagine an online banking website. A user changes an account number in the URL and suddenly sees another customer's information because the server doesn't properly verify permissions. Prevention: always enforce authorization checks on the server side and apply the principle of least privilege. 2. Cryptographic failures. Sensitive information needs strong protection. Example: a website stores passwords in plain text instead of using secure password hashing. If the database is exposed, every password becomes immediately readable. Prevention: use modern password hashing algorithms, encrypt sensitive data, and require HTTPS for data in transit. 3. Injection vulnerabilities happen when an application treats untrusted input as part of a command or database query. Example: a search box sends user input directly to a database without proper safeguards, allowing an attacker to manipulate the query and retrieve unauthorized information. Prevention: use parameterized queries, prepared statements, and strict input validation. 4. Insecure design. Sometimes the problem starts before any code is written. Example: a password reset feature allows unlimited verification attempts without any rate limiting, making it easier for attackers to guess reset codes. Prevention: build security into the design process using threat modeling and secure architecture reviews. 5. Security misconfiguration. Incorrect settings often leave applications exposed. Example: a production server still has default administrator credentials or debugging features enabled, giving attackers unnecessary information. Prevention: disable unnecessary services, remove default accounts, and regularly review security configurations. 6. Vulnerable and outdated components. Most applications depend on third-party software libraries. Example: a company continues using an outdated framework with publicly known vulnerabilities instead of applying available security updates. Prevention: keep dependencies updated, remove unused components, and monitor security advisories. 7. Identification and authentication failures. Weak authentication can lead to account compromise. Example: a website allows weak passwords and doesn't offer multi-factor authentication. If a user's password is reused from another breached service, attackers may gain access. Prevention: require strong passwords, support MFA, and securely manage authentication sessions. 8. Software and data integrity failures. Applications should verify that software and updates come from trusted sources. Example: an organization installs updates without checking their authenticity, increasing the risk of introducing malicious code if the update source is compromised. Prevention: use digital signatures, trusted repositories, and secure software supply chain practices. 9. Security logging and monitoring failures. Without proper monitoring, attacks may remain undetected. Example: repeated failed login attempts aren't logged or alerted, allowing suspicious activity to continue unnoticed. Prevention: record important security events, monitor logs, and establish incident response procedures. 10. Server-side request forgery, SSRF. SSRF occurs when a server is tricked into making requests to unintended destinations. Example: a web application lets users submit image URLs. Without proper validation, the server could be induced to request internal resources that should not be publicly accessible. Prevention: validate destination URLs, restrict outbound network requests, and isolate internal services. Why OWASP Top 10 matters? The OWASP Top 10 isn't just for ethical hackers. Developers use it to write more secure applications. Security teams use it to prioritize testing. Organizations use it to improve their defenses and reduce the likelihood of common web application attacks. Learning these concepts is one of the best starting points for anyone entering cybersecurity. Now you know the 10 most important web security risks highlighted by OWASP. Understanding these vulnerabilities is the first step toward building safer web applications and recognizing common security issues during assessments. If you found this video helpful, don't forget to like, subscribe, and turn on notifications for more ethical hacking and cybersecurity content. Thanks for watching, and I'll see you in the next video.